Hello everyone. Good evening. Boa tarde. Dobry wieczór. Bonsoir. Buenas tardes. Assalamu alaikum. My name is Anna Buffa, and I'm happy to welcome you to this new webinar session planned by Ocrim. I'm a food entertainer and I work in communication food since 15 years, and I will enjoy with you this webinar. Now some indication about it. It will last 1 hour. In this time, you can ask your questions, and you will be able to ask the speaker at any time you want through your Q&A section. Will be 2 moments dedicated to them. The first one after the middle part of the presentation, and at the end of the presentation. The most complex question will be answered by mail, and you can write to conferenceroom@ocrim.com. Questions are anonymous, so don't be shy. You can do all the questions you need. And this new appointment is about the second part of technological tips by Ocrim. Last time, Marco Galli talked about the differences between high efficiency flow and standard flow, focusing on the future trends of the flower market, which are flower with low ash content, very white flowers, and very fine flowers. Today, Marco will approach a new topic, which is the stock improvement through roller mills, better known as SIR concept. I'm very glad to introduce you Marco Galli, which is the Ocrim Chief Technologist. He works in Ocrim since 1983 as a miller apprentice. In 1993, he became Ocrim Technology Manager in Bogasari Flour Mill, the largest milling plant in the world. And he's very known as eager for novelties and knowledge. He has different patented invention filed in his name. So I'm very glad to say hi to Marco Galli, and good afternoon.
Thanks, Anna. Il microfono. Thanks, Anna, and good day to all, and welcome to this second webinar named by Ocrim Tips. And today, as mentioned by Anna, we will talking about 2 topics mostly, which is the cleaning product through the roller mill and the quality division of or distribution of the products due in the flow sheet. So we start from where we finished yesterday, last webinar with the numbers. Just a second, we change the slide. Give us a second. Here we are. So in this slide is the conclusion for the first webinar, where we see that we maximize the low ash flour with fine granulation flour, which is our goal, which is our topic, increasing the number of distribution products in the head of the reduction system. And this is some numbers. So from that point, today we'll go in another part of this concept, which is the stock improvement through the roller mill and product distribution quality by or based on quality. Those 2 aspects, they are linked one to the other because one needs the other one for to have a good result or to complete the result that we are looking for. Considering that we are talking about a comparison between 2 flows, high efficiency flow, which is a flow dedicated to obtain high extraction on low ash flour, and with very fine granulation, compared a standard flow that has more or less the same target, but with different concept. And we will see the differences in the end by numbers. So let's recall a little bit what we say during the last webinar. The use of the purifier. Purifier is equipment that for this type of flow sheet, for this type of requirement or product is a must. But purifier also has some limitations. We cannot use purifiers everywhere. We cannot clean all the products by using purifier. So purifier has to be used where we can optimize this one. We can optimize the performance of the machine. The second aspect of using purifier is that only cleaning a semolina by purifier, we will not obtain the result that we are looking for. We need something else. We need to have the purifier in order to obtain as possible as low ash flour and at its maximum extraction. So how we can combine the use of purifier in order to obtain the result that we are looking for. So this will be the target of our webinar today. And in order to answer or to try to justify how we will approach this, let's say, support to the purifier, we need to make a statement and understanding what is the difference between endosperm and bran under a physically point of view. So when we grind endosperm and bran, their behaviors is different according to the situation. So the endosperm is reduced in flour or becomes smaller because it's friable, so it's reducing in size. And in the other hand, the bran through the roller mill will flake, will becomes bigger. So this difference is something that we can use in our to help us in order to clean product, in order to have better product. And this is what we are trying to use to make cleaned product during the flow. And this is the Ocrim concept, the concept that we are trying to share today, which is the stock improvement through the roller mill, or what we can say the SIR concept. The concept, we didn't invent anything. The concept is already there. We are just using this technology, this approach in different way inside in the mill or inside in the flow with more extensively application. So this is something that, this concept is something that could help the product be cleaned when we cannot use purifier. When we grind any type of product, we will have a dirty fraction that comes out. Removing this dirty fraction from the streams is something that allows to have a cleaned product in a dedicated passage. And this will complete the cleaning, degrading of all products by purifier in one hand and by the SIR concept on the other hand. In this next slide, we will see physically by picture how the products appear. So we have the product which is coming in, and we have the process of the SIR application and the visualization concept, let me say on that way. So the concept of SIR can be divided in two parts. One is the grinding, where we break down the endosperm in a small passage and we flake the bran. Doing that one, we move to the second step, which is the sieving one. And the sieving will separate by size the coarse product, so which will be the bran or the briny parts, from the smaller one, which could be flour or cleaned product, more cleaned product. We will see later on during this presentation, during this webinar, that we will translate this feeling in numbers just to make you more confident on using it and how is important to have it. Just a small, a brief list of benefit and how it can be applied. So with this system, we will have a hash concentration. What means for our hash concentration? We have fraction with very high hash and fraction with very low hash, even starting from a middle product. This will drive us with a very important point. In the flow, we can concentrate dirty products, high hash, and fine fraction or low hash. Eliminating the bran from the residual product that is running, especially in the head of mid-links or sizing, we allow to have low ash flour because we have low ash product moving around. Then, having this concept applied, we will have more destination, which is correlated to the passage steps during the flow sheet, and we will see that one clearly indicated. So all this will drive to have a cleaner product which allow to increase the low ash flour extraction. The applications, we can use that one when purifier cannot be used, and also with for the capex optimization. When I mean capex optimization, I consider that, for example, purifiers are more expensive than this system, and we have to use purifier when really we need it. So let's see the practical application and some data related to that. It's important to define that we are talking about two totally different passages, and we will see the comparison of these two different passages after the SIR concept application and above and below 280 microns. So we will have first passage which will analyze the incoming product has more or less 1.4 hash content. The product after the SIR application, we have the fraction below than 280, which in one case is 0.48 and in another case is 0.37. So this is already a first condition. Through the roller mill, we can clean the product. At least we can clean partially a certain amount. And this is thanks to a right configuration in the roller mill, a right granulation range, because if we have a mixing granulation, we cannot optimize the grinding, and a proper configuration of the sifter. So all this impacts the ash content, lowering the ash in the products. If we go for the next data, we add more or less the percentage of each fraction. So we enter in the roller mill with with 1.4, for example, in one passage, or 0.56, and then we split in two products with about 65 to 35%. 65 is the cleanest one, 35 is the dirty one in one example, or 0.37 ash content, about 86% extraction against 1.8 versus 14% extraction. So this means that it's possible, is possible to have low ash products or stream, even if we have very high ash content on the incoming. And it's important also the ash content concentration, because this will allow you to have a well-defined passage where concentrate those products, avoiding the turning around in the flow, because as this product continues turning around, they will contaminate and create problems to extract low ash flour. Let's see this concept applied in parts of the mill, starting from the sizing passages and comparing the two flows. one point that I would like to point out, and we can see clearly here, is the concentration of passage. What I mean for concentration of passage? In the standard flow, we have more or less same number of equipment that we have on the high efficiency flow, but they are just concentrated in 4 passages. State in the high efficiency flow, we are distributed in 6 passages. This is a huge benefit because this will allow you to have more cleaning passages, more cleaning options using the SIR concept. And this is the proving. If we compare what we have just on the sizing passages, we will have an average lowering ash about 10% on the high efficiency versus the standard one. Flower extraction increase about 7-8%. Total improvement, according to our index, is about 17 to 18%. Then later on, we will see how why we have those numbers. But let's continuously compare again the head of the sizing together with the head of the middling passages. So even in that case, we can see how drastically we increase the number of passages. So we have less concentration, we have more cleaning cycles in the standard flow compared on the high efficiency flow. And this drive us to the comparison now just on the middling passage, which we move from 2 passages to 4 passages. So we increase by 15% more or less the cycles for cleaning. The average is 11 to 12%, the lowering ash. The extraction increase about 16 to 17, and the total improvement, according to our index, is about 27 to 29. And this, I think, are the really good numbers. Now, to conclude this first comparison, we can put together the sizing and middling in just one table, which allow first to indicate that we increase the number of potential cycles to clean through the SIR concept. We are talking about 40%. Then the numbers, the average number is about 9 to 10%, the reducing ash content on the total flower, increasing the extraction about 11 to 12 to have a total improvement about 20 to 22. But the key point is the distribution of passage. So avoiding the concentration or having a lot of grinding surface in the small number of passages. This is the key if you want to go on this type of flow or if you are looking for this type of product. Then, how to compare or how to emphasize the aspects, negative and positive. The extensively utilization on the middling passage about the SIR concept, thanks to the more steps or more passages that we have. We have a distribution between coarse products and dirty products. They don't still going around in the same group of passage. For example, there are flour mills that always, even the coarse product from the middlings, they stay in the same group. In our case, we avoid to having this product going around in the same group because dirty products create just dirty flour. So we have to remove, and we can do that with the SIR and the correct distribution in the flow sheet. And this drives to have passage with where we can grinding without no compromise on any aspect. And doing that one, we don't compromise the low ash flour extraction. Of course, the negative impact is in some flow, as we say, we have the dirty fraction that just turning around in the middling passage. And this, sooner or later, will create a cross-contamination between products. And with this cross-contamination will impact the ash and color specs that we are looking for. So those are the pros and cons related to the two in the two flows. Now, how is possible to achieve higher flour extraction with low ash? For me, it's very simple and logical, but let's go through this one. First, because we are processing products with homogeneous size distribution and quality distribution. And we know that grinding product with homogeneous size distribution and quality is easier. We don't have any compromise. We just need to do at its best to extract as much as possible when we can the flour. Optimized grinding is a consequence of the previous step. So as soon as we divide it in properly sized, then we can optimize the grinding. We can even grind hard on that part because we are not afraid to break any briny fraction. This leads to the SIR cleaning concept, because through the SIR, we can use the roller mill to clean, create a cleaned stream to grind better according to what we say in these two passages or in these two previous steps. The result is having the possibility to grind as much as possible on the cleaning passages, we will have higher extraction. Then, if the product is cleaning, we will have higher extraction with low ash flour. So this is the sequence that we have to apply in order to achieve both extraction and low ash flour. Let's say now we complete our first part. Let's see if we have any question or any clarification in order to start to open the discussion if we have the chance. So Anna, it's your turn now to see if we have something.
Yes, thanks Marco for your first part of presentation. So the first question is, what is the minimum granulation quantity to be processed with purifiers?
So unfortunately, there is no numbers on that. First of all, is important to divide it in the approach into hard wheat or durum wheat. Durum wheat has to produce semola, or semolina, so we need to have a special product just which is granulated product. So this product cannot be cleaned through a sifter, has to be cleaned through a purifier. In this case, we accept to have more purifier. So in case of durum, the purifiers is allowed even to clean product below 200 microns. In the hard wheat, it's not economically doing that. You can do, but it's not economically. So I will say in the hard wheat, processing products below than 200 micron is not economically. So I will say, even if we don't have any number, I will say the limit is something between 250, 200, not less than that. If we want to go less than that, we have to use what we are calling a SIR concept or cleaning through the roller mill. This is my experience.
Okay, we have another question. Are the ash levels shown percentual dry matter or 14% moisture basis?
All the data we are sharing are in dry basis. So moisture basis, there will be less. The question is good because it's important to clarify that all these numbers are on dry basis.
Okay, we have time for the last one. How does the milk capacity impact the configuration of the flow according to the HEF?
So the capacity impacts the number of equipment. The number of equipment drives for the configuration of high efficiency flow. Theoretically, the high efficiency flow can be applied to any capacity. Of course, smaller is the capacity, less equipment you will have, and more difficult will be creating the steps of passage that we need. So this is the reason why the high efficiency flow is not suited or is more adaptable for medium higher capacity. I would say flows below than 150 tons, 200 tons, they start to be difficult to achieve the numbers of passage that we need to guarantee a concept like that one. If we are talking about 200, 250 tons, so is already a capacity that we can manage. Of course, the ideal capacity is something above 300. Another important thing is that one. We are always talking about fine flour and low ash flour, which is a special product for certain market area. And those market area, they know that to obtain this product, we need a kind of well-sized equipment list. We can, for example, we cannot do this type of product with a grinding surface about 10 millimeters. So it's a combination of many aspects. The conclusion is we need to have a certain capacity. The target, the break-even is around 250, 300. Above that, there is no problem. Below that, it's quite difficult to balancing equipment and configuration.
Okay, Marco, I suggest to go on with your presentation, so we'll be in time.
Okay, so a second aspect that I would like to share with you, and for me is important as well, and is an integration of how to divide product by quality and how we grinding this product, especially in the flour mill where we have purifier. So is the concept related to the second grade product processing. And in the high efficiency flow, we have this process which divide the passage in two. So we will have the product comes from purifier divided into one are the overs. So the product that are overs from the screen from the sieves. And the second product is the pass-through. So is a product that has been selected, but is not enough clean to load the head of the middling or the head of the sizing group. So it's the unclear product, but is a product with a lot of potential. By dividing this, we can take all the potential from this pass-through product, leaving the overs, which they are the really dirty one, and the coarse one, on the dedicated passage. The aim of this one is always to reduce the ash on flour, increasing the low ash extraction. And we will see here how will be the benefit by numbers. Now, on this screenshot, we see the approach on the two different flows. Standard flow, we have one passage for the same capacity. We have one passage concentrated more different grinding surface. In the high efficiency flow, we have divided coarse and fine, and we have this product that will be loading. Alternatively, coarse and fine passage according to the ash content or the quality of the product. Okay, this is a concept also that is even more important when we apply the SIR concept, because in the configuration of the high efficiency flow, we have, of course, the main loading of the second quality streams will be the purifier, but we have also overs from the middling that goes in this passage, and these overs, they are the product split during the grinding through the SIR concept. So how we process? We have the separation of, like more or less summarizing like that one. We have a fine stream, which is the second grade semolina from purifier sieve. So it's the product that is not enough clean to go from the first passage of sizing or middling, but not enough cleaned, but not enough dirty to be rejected by the machine. The second stream is the coarse one, so it's the dirty overs from purifier that has their own dedicated passage together with the middling passage head from the sifters, so are the overs. This, the big advantage is avoiding the mixing, which any mixing downgrade the quality product, creating a cross-contamination, which makes impossible to extract low ash flour. And this is the numbers. Always we are talking about dry basis numbers. So we have the two streams, which is ranging from 0.57 to 84, 0.84 on the cleaned one and the dirty one against the 0.68. The flour that we can collect on first quality, second grade sizing is 0.4. The second one is the flour on the second quality product is 0.54. When we combine these two as the example of the standard flow, we have 0.5. So the consideration is, with this distribution, we're still having flour below 0.4, considering that our target is 0.45 dry basis, we're still far below from our target. On the other hand, on the standard flow, even if we try to correct something in the flow, in the sifter flow, reduce the granulation of the flour, make some kind of adjustment, we are still far away to obtain the flour that we are looking for. So it's the 0.45. Now, in the new data sheet, we will see also the percentage that we have. So we say we will extract about 46% of flour on that passage below than the 0.4. But the other advantage is also that in the second passage, so from the dirty one, we will recover a kind of flour which is not good, but still lower in ash. Okay, and it's important that the second step, which is the concentration on ash, which is really important, because in a flour mill, if we concentrate as much as possible dirty product in certain passages, we will have benefit on the rest of the product, on the rest of the passages, because we are able to say, we will process clean product at its best, we will process dirty product at its best. The result of this one is just increasing low ash flour extraction. And I repeat, this is thanks to the concept of SIR that we are using here. Then another important concept is, and basically concept for a good flow sheet is the segregation by quality. So what do you mean? What we mean for segregation by quality is a correct distribution by quality through the roles. This needs also a correct distribution, grinding distribution, roll surface according to the product. So one is helping the other. We need the correct homogeneity by quality, so based on ash content. We need a correct segregation, homogeneity by particle size distribution, because only by using this segregation, we can have quality products and we can extract our low ash flour. A good example of this one and how to process this is what we call DD1, or the first grade, the product coming from the first grade, which is below than 224 microns. The first grade is the passage that receive the stocks from first and second break. So it's the cleanest, theoretically, is the cleanest product, or the optimum product from where you can extract the high quantity of low ash flour. And here we are comparing the product that comes from the first grade below than 224 micron ash, comparing to the head of middling. Why we are comparing to the head of middling passage? Because they are similar in granulation. The question is that this product is rich in semolina, but is contaminated. Due to the granulation, it's almost impossible to clean by using purifier, or you can clean by using purifier, but it becomes expensive. If you mix this product together with a very low ash product or top quality, this product can compromise the low ash flour extraction. But on the other hand, if you're mixing too late in the grinding passage, maybe this lead to you to lose the yield. So it's important to properly understand where to mix this product. Then, if you have a concentration of passage, you don't have so many choices. You can have more choices if you have different passages and more distributed passages in your flow. So again, to properly process this product, the best solution is multiple steps in order to identify the best combination, which is in our case is C1B. So we protect all the real head passage, obtaining from where we obtain very, very low ash flour. But also another important consideration is that, and this will easily explain why we have an increasing ash content from C1 to C1B. And this is the same concept that we reduce the quality, the flour quality from the top to the end, to the tail of the flow sheet. Why we have this one? The answer is easy and is clear. Always, and is almost correlated to the SIR concept. Always, when you're grinding, you remove, in this case, a flour. Flour is the low ash product. And what you don't still to be regrinding is the higher in ash flour. So this automatically downgrade the product in the next roller mill. So it becomes more difficult to remove, to extract low ash flour from a dirty product. How we can mitigate this? We can mitigate this applying the SIR concept in two steps. One, to create low ash flour. The second one, to create a very high ash content stream, which allows you to have a medium stream with a fair ash content from where you can extract good quality of flour. Of course, to doing that, you need to have a certain passage numbers. You cannot concentrate your passage. So you will benefit the SIR concept if you have the more passages and not concentrated passages, just in few steps. Now, in order to conclude, let's say to start to concluding our talking, our presentation, let's compare, let's doing a general comparison by quality parameters on the high efficiency flow compared to the standard flow. So we have that the minimum ash content in the high efficiency flow, which are using all the concepts that we are sharing today, we move from 0.36 to 0.34. So we reduce the best ash content flour about 6 to 7%. Then we increase this extraction because it moves from almost 0, 1% to 5 to 6. Consequently, we increase the ash content, the extraction of the flour below 0.4 ash content from 38 to 39 to 42 to 43, about 10%. The same increasing we have on the ashes, on the flour ashes below 0.45, with the same extraction, because the test we did is with more or less the same extraction. So finally, we have a reduction with the same extraction on around 62 against 66. Now, if we do vice versa, instead of fixing the ash content, instead of fixing the extraction, we fix the ash, we will have that the standard flow has 77, but the high efficiency flow can increase the extraction by 2 to 2.5% in order to reach the target ash, which is in that case 0.66. So those are some indications that helps in order to understand the concept and proving how the concept are, the goodness of the concept. Now, let's go and see if we can retrofit this concept in a general flow. On my opinion, yes, there is a lot of space to retrofit, especially when we use a purifier. For example, we have the second grade product that can be splitted, as we saw on that previously on the slide. We can apply the SIR concept almost extensively. Every single passage can be used with the SIR concept. Of course, the best result we will have when we combine granulation and passages distribution. But we can apply this. This is our concept that is easy to retrofit, and the most nicer part of this is almost no cost impact, because we have already the equipment, we have already the machine placed. It's just to find a way to retrofit those machines and to reconfigure the loading of that machine. But let's go for the last question. Is the high efficiency flow require more equipment? Does the high efficiency flow require more equipment? The answer is no. Is not, and we will see why we don't need more equipment. Because the concept behind this is not adding equipment, but is using in a different way equipment. Today, we are not anymore in the era to increase the equipment number. We are in the era where we have to optimize what we have. We have to optimize everything. We need a well-balanced equipment list, but we don't need to exceed. No one will pay for that. So what we have to optimize. And this we can see from the head of the reduction. We see the numbers, the ash contained. We see the result on the extraction. Here we see how we split in the high efficiency flow and the standard flow. We see that the difference is minimal. We are talking about 1 meter, half roller mill maybe. So in this case, and this is the proof, the numbers ash contained and extraction was shared before. Here we have just the grinding surface. The conclusion is that we don't have extra equipment. We just apply concept. We apply a particle size concentration concept, which is different in the high efficiency versus the standard flow. High efficiency has more cleaning cycle. We see that always when we clean through the roller mill a product, we have better result. The SUR utilization, according to our experience, make a lot of differences on that one, especially when you have to produce fine flour and low ash flour. This is a concept that has to be always considering. Let me say, if we can do the same with less equipment, is a good advantage. Is an advantage because you have less footprint in your building, you have less maintenance, you have less equipment that could broken, you have less, but you still obtain more quality product. And this is the final comparison that we can share. So this is passages by passages. We have the percentage and so on. Even the quantity of passages in the same groups, they are similar. The question is how many steps we have. We see that we move from 6 to 10 in the middling passage. We increase about 40% on the head of reductions. The distribution passage. So from concentrated to more spread passages, we have this. The conclusion is we don't need extra equipment. We just need more to reduce the passage concentration. We need more passages and we need more extensive SUR application, SUR concept application. And to conclude, we're still having to satisfy the market demand. The market is the one that drives us. So we have to satisfy. In our case, market demands for maximize low ash flour. Market is demanding to reducing or optimizing capex. Market is demanding to not impact in the building and in the maintenance cost. Because if we go on that way, we will have impact on the capex. The project will not be so attractive. So we will have longer time frame for the return of investment. The market is demanding for short time, is demanding for concentrating, for building more compact. So the solution of Ocrim on this flour mill are that one, well-balanced equipment list, stock improvement through roller mill, the SUR concept, and proper qualitative and granulation distribution. Those are the aspects. I am convinced that a good flow sheet can give you a good and best result. without increasing the number of the machine. Increasing the number of the machine is the easiest one, but someone has to pay for that, and not everybody else will. I hope the time that we are spending together is interesting. I hope you could appreciate, you could use in your meals these tips, this indication we are sharing. And now it's time to see if we're still having some questions, and let me see if we can reply. And here we are.
Thanks, Marco. Your presentation was totally clear. So we have few questions. First one, may corrugated rolls be used to obtain SIR benefits?
The answer is no. You cannot, okay, you may use corrugated rolls, but you will not have the benefit that you will have by using the smooth rolls for the to have a SIR concept. So the benefit of the SIR concept is mostly related to the smooth rolls. This is an important aspect, because corrugated will cut the bran. We need to flake the bran. This is the reason why corrugated rolls could impact negatively the quality of the SIR concept in a process like that one, or in a process like a flour mill to produce low ash flour.
Okay, clear. Double high rolls versus granulation range and SIR concept. What do you think?
Double high rolls, of course, can be used. We use that one, but is let's say is something that reduce your passage, reduce the number of passages that you have, because it's a concentration of 2 passages in one machine. So doing that one, you potentially has less cleaning cycles. So as soon as you concentrate your product in one machine to make in one passage what you could do in 2, of course, is something that will compromise your quality, the quality of your process. So yes, you can use double high roller mill. You have to be very clear, very careful on using it, because you have to process very clean product on that one, because you have to optimize the extraction. If you do like that one, yes, you can use. But if you start to using double high roller mill with different granulation, not proper cleaning product, then this could be a compromise that can impact your final quality product.
Okay, last question. We had a similar question like yesterday, I suppose. Is there any ash range for product quality segregation?
As I mentioned yesterday, no, there is no, because depends. We saw that depends on the mill capacity, depends on how many passages we have, depends on how many steps we want to do. So depends a lot on how we configure the mill. Of course, bigger is the mill, easiest is to concentrate the ash content on single passages. Smaller is the mill, more concentration of product in a single passage we have to do. Of course, depends on this. There is no numbers. In the flour mill, there is no standards, because we are working with a live product, which can change from summer to winter. So it's important to understand the process and how to manage the process. Not looking the standard numbers, because the standard numbers not always can be replicated.
Okay, Marco, no more question, but just a few compliments to people. Thank you for the excellent webinar and the excellent way to expose you have.
Thank you. Thank you.
I'm sorry. We thank you all for your attention, and follow us on our social, on LinkedIn, and keep updated for the next webinar. Thanks, Marco. Thank all.
Thank you, and keep safe to everybody. Bye-bye.